In this video, I am going to explain about memory protection using two registers called base register and limit register. Okay, why we need this first of all protection? We know that whatever the program we want to execute, that program should be in their main memory. Okay, whatever the programs in the secondary memory, first we need to brought into the main memory, then only our processor can able to fetch from the main memory. So, and also we know that almost 50% of our main memory, 50% of our main memory will be occupied by operating system and some other system softwares. Okay, that also we know that. Okay, now you see, generally our main memory size, our RAM size is what? 8 GB, 12 GB, 16 GB, 4 GB. Instead of taking 4 GB, 8 GB, the larger number, I will assume my main memory, so in this example, the main memory is of size, say, 40,000 bytes. Okay, 40,000 bytes. That means, see, there 4 GB or 8 GB. B stands for bytes. Okay, here. So for now, in this my memory size 40 KB. For simply, I am taking some smaller number. That's it. Okay. So now we know that our main memory starts from the address what 0. Assume I told almost 50% of our main memory will be occupied by our operating system and some system, other system softwares. Okay. Now 50% means out of 40,000, 20,000. So that means up to 20,000 means 19,999. Okay. Up to this 0 to 20,000. See 0 to 19 is 100. Since I am starting 0 up to 19,000, so total 20,000 is occupied by operating system. So next onwards, so these are the spaces available for our user programs. Okay, user program, and this is what? Operating system or system programs. So now assume after loading the operating system, we have moved one process. For example, say process 1. Process 1 will occupy, and then after process 1, assume we brought one more process, say process 2. Then after that again I brought one more process, for example, say process 3. Okay, and this is vacant space. Okay, this space is still free. Okay, so now the 40,000, the last one is how much? Last one is 39,999. Okay, so 0 to 39,999 means 40,000 total more. Okay, now assume up to here. So now process 1 starts from what? 20,000. Next address is 20,000. And process 2. Process 2 starts at, for example, I am saying say 21,000. For example. And process 3 starts, for example, 23,000. Okay. And process after this from say 23,800. 23,800 to 39,900, this memory is free. Okay, this much is occupied by the user programs and this is OS programs. Now, since both user program and as well as the operating system programs, both are there in the same main memory. That means user program and system program both are sharing the same main memory space. So there may be a possibility of any one user program, instead of accessing its own data or instruction, user process try to access the code or instruction belongs to some other process. Or sometimes our user program, instead of accessing its own code or its own data, it will try to access the code or data belonging to the operating system. We should not allow for this. Okay, for example, we know that whenever a program brought from the secondary memory into the main memory, it will be what? It will be stored as what? See, every process is having its own code segment, every process having its own data segment, stack segment, heap segment. That means every process has its own code segment, has its own data segment. Similarly, there is one more process. Say this is for process 1, process 2. Okay. Say code segment, data segment, stack segment, heap segment. Now, process P2 should get its own data. It should never take data of this one. Similarly, process P1 should take data or code only from belongs to its segment, not others. That means one user, see, we should give protection for user program in such a way that no other user program should access the data or code belongs to other user programs. Similarly, we should give protection to our what? Our operating system programs and systems of programs also we should give protection, so that no user process or no user program affect this, or no user program affect other user programs. Okay, for this purpose we have to give what? Protection. That's what the memory protection. So that means we should give protection for every process's data and code segment, so that no process should get affected by other process, or no user process should affect other operating system process also. So we should give that protection. That protection is given by using two registers called base register and limit register, and these registers are stored inside the CPU. So nobody are ready to what? Nobody can edit that. So these register can be edited or can be loaded or can be accessed, can be used only by the processor, not by anything. So we can have protection, okay, safety. So that we will see. Okay, now let us take in this example, there are three user processes are there. Assume process 2 has to access, whenever process 2 wants to take its data or code, whatever, it has to take only between the addresses 21,000 to 21,000 to 22,999. Okay, that means 22,999. Between, in this only it has to access. It should not access the data anything greater than 22,999, that is from here or from here, that means lesser than 21,000. You should access only in between these addresses, only it has to access. How it will be done using base and limit register, that we are going to see now. Okay, now base register. So base register contains the starting address of the process. Okay, now here process 2 starting address is what? It starts from what? 21,000. So base register of every process has its own base register and limit register. So base register of process 2 is storing the address 21,000 according to this example. Okay, so now limit register gives us the information about the size of the program, size of the process. Now, what is the size of the process? Say 21,000 to 22,000 means 2,000. That means this size is 2,000. That means there are 2,000 bytes are there, or 2,000 instructions are there, or 2,000 data is there, like that. Okay, that means this block. Okay, so 2,000 bytes are there. Okay, so that 2,000 bytes only it can access from this address to this address. We know that base register and limit register. Base register contains the starting address and limit register contains the size of the program. How many number of instructions are there? How many blocks are there? How many bytes are there? Okay, so now we know that whenever CPU takes the instruction, executes, it generates a logical address. Okay, logical address. Okay, so whenever CPU executes any instruction, it generates one logical address. Logical address. That logical address we need to check whether process 2 is accessing the data instruction in between these other addresses only or not. We need to check. To check what we are using, so we know that in the flow chart we are using what? This diamond symbol, right? Okay, so now I have to check. So with whom I have to check? Now I need to check this with the what? Base register first. Okay, so base register contains what? Starting address. I will take this base register. Now, this process 2 has to access starting address is what? Starting address. You should access starting address to 21,000. 21,000 is there where 21,000 is in base register. So I take base register. So whatever the instruction, see, I will rewrite this one separately. I rewrite this one, especially what? This process 2. Okay, process 2 for example. So okay, this is my what? Process 2. And this first instruction starts at address what? 21,000. The last instruction is 22,999. Okay, now whenever this process P2 P2 process 2 wants to access the first address is 21,000. That is there in the base register. So only this instruction. What about the next address instruction? Next instruction address is 21,001. Next instruction is 21,002. Like that is increasing. So what? So now whatever the logical address CPU generates for this process, it should be what? Greater than or equal. Greater than or equal to process this one. That means if process 2 can access anything greater than 21,000 or equal to 21,000 from this first instruction, it can access any instruction. Any instruction. So that's what. Now suppose this is true, fine. If this is true, then now what? I said only about, but there is a limit. So there is no, that means up to where? From 21,000 it can, from 21,000 can access anything? No. There is some what? Boundaries there. What is that boundary there? That is there in the limit register. So now what I will do? So now I will check before. Now process 2 should access from 21,000 equal or greater than 21,000 and it should be lesser than what? I don't know this actually. I don't know this. But it should be, see, but process 3 starts from 23,000. So process 2 has to access data below 23,000. That is should be lesser than. So now again I need to check that address should be greater than what? 21,000 and it should be lesser than what? Should be lesser than what? 23. Now, how I get 23? I don't know process 3 or starts from 23, but I know limit. If you add these to see, I will get 23. If I add 21,000 plus 2,000, I will get 23. So now I will take base register plus limit register. Now with this I will check. Okay, we will check and it should be what? Lesser than that. If this is true, then only I am allowing to get what? Access into the main memory. Access into the main memory. If it is what? Yes. If it is yes. Suppose if it is no. Suppose if it is greater than. Okay, no. Suppose check logical address generated. That is not greater than or equal. Not greater than or equal means it is obviously lesser. 21,000 lesser than. Again here anywhere it can be allowed. Process 2 can be allowed to access in. No. So you generate one trap. That is an error trap to operating system. This is software interrupt trap. Okay, generate one software interrupt to operating system indicates that this process is trying to access somebody else's code or data. Suppose here it says it is true, correct. It is greater than 21,000. True. But it is not lesser than 23,000. But it is not lesser than means what? It is accessing other than that. Okay, then also we should not allow. Then again we should send some fatal error. Okay, some fatal error we should say. Okay, so this is what this is how, so both the conditions are true. That means I will check whether it is greater than this and lesser than this, then only I am allowing to access the main memory. Otherwise I am not allowing this program. So this is how we can give protection for every process using the base and limit registers. So that's what memory protection using base and limit register. Hope you people understood this concept. If you have any questions, please write it in the comments. Thank you.